Chapter 30 of Astronomy, The Science of the Heavenly Bodies by David Todd. Total eclipses of the sun. Primitive peoples indulged in every variety of explanation of mysterious happenings in the sky. To the Chinese, and all through India, a total eclipse of the sun is caused by a certain dragon with very black claws, who, except for their frightening him away by every conceivable sort of hideous noise, would most certainly eat up the sun. The eclipse also goes off. The sun has never been eaten yet. Can you convince a Chinaman that Rahu, the dragon, would have eaten up the sun if his unearthly din hadn't frightened him away? In Japan, the eclipse drops poison from the sky into wells, so the Japanese cover them up. Fontenelle relates that in the middle of the 17th century, a multitude of people shut themselves up in cellars in Paris during the total eclipse. In the Shu King, an ancient Chinese work, occurs the earliest record of a total eclipse of the sun, in the year BC 2158. The Nineveh eclipse of BC 763 is perhaps the first of the ancient eclipses of which we possess a really clear description of the Assyrian eponym tablets in the British Museum. It is the eclipse possibly referred to in the Book of Amos, chapter 4. But of all the ancient eclipses, none perhaps exceeds in interest the famous eclipse of Thales, BC 585, May 28th. It is the first eclipse to have been predicted, probably by means of the Saros, or 18-year period of eclipses, which is useful as an approximate method even at the present day. But the accident of a war between the Lydians and the Medes has added greatly to the historic interest, because the combatants were so terrified by the sudden turning of day into night that they at once concluded a peace cemented by 2 marriages. Very many of the ancient eclipses have been of great use to the historian in verifying dates, and mathematical astronomers have employed them in correcting the lunar tables, or intricate mathematical data by which the motion of the moon is predicted. Coming down to the middle of the 6th century, we find the first eclipse recorded in England, in the Saxon Chronicle, AD 538. During the epoch of the Arabian Nights, several eclipses were witnessed at Baghdad, AD 829 to 928, and many a century later by Ibn Yunis, court astronomer of Hakim, the Caliph of Egypt. Nothing is more interesting than to search the quaint records of these ancient eclipses. One, occurring in 1650, when Tycho Brahe was but 14, had much to do with turning his permanent interest towards mathematics and astronomy. The eclipse of 1612 was the first seen through a tube, the telescope having been invented only a few years before. Paradise Lost was completed about 1665, and the censorship was still in existence, and it is a matter of record that the oft-quoted passage, "As when the sun, new risen, looks through the horizontal misty air, shorn of his beams, or from behind the moon, in dim eclipse, disastrous twilight sheds, on half the nations, and with fear of change, perplexes monarchs," was strongly urged as sufficient reason for suppressing the entire epoch. London was favored with the outflashing corona, May 3, 1715, and a pamphlet was issued in prediction entitled The Black Day, or A Prospect of Doomsday. The first American eclipse expedition was on occasion of the totality of October 27, 1780, sent out by Harvard College and the American Academy of Arts and Sciences under Professor Samuel Williams, to Penobscot. There was a fine total eclipse from Albany to Boston on June 16th of 1806, and many important observations of it were made in this country. But it was not till the European eclipse of 1842 that research got fully underway, because the germ of the new astronomy, particularly as applied to the sun, had begun its development, and the significance of the corona was obvious, if it could be proved a true appendage of the sun. Photography had not long been discovered, and the corona of 1851 was the first to be automatically registered on a daguerreotype. In 1860, it was proved that prominences and corona both belong to the sun and not to the moon. The Great Indian Eclipse of 1868 brought the important discovery that the prominences can be observed at any time without an eclipse by means of the spectroscope. In 1869, bright lines were found in the spectrum of the corona, one line in the green indicating the presence of an element not then known on the Earth, and hence called coronium. In 1870, the reversing layer or stratum of the sun was discovered. In 1878, a vast ecliptic extension of the streams of the corona, many millions of miles both east and west of the sun, was first seen. This is now known to be the type of corona characteristic of minimum spots on the sun. In 1882, the spectrum of the corona was first photographed, and in 1889, excellent detail photographs of the corona were taken. In 1893, it was shown that the corona quite certainly rotates bodily with the sun. In 1896, actual spectrum photographs of the reversing layer established its existence beyond doubt. Flash spectrum, it's often called. In 1898, the long ecliptic streamers of the corona were successfully photographed for the first time. In 1900, the depth of the reversing layer was found to average 500 miles. The heat of the corona was first measured by the bolometer, and many observations showed that the coronal streamers, in part at least, partake of the nature of electric discharges. All subsequent total eclipses have been carefully observed in whatever part of the world they may happen, and each has added new results of significance to our theories of the corona and its relation to the radiant energy of the sun. In very recent eclipses, this cinematograph has been brought into action as an efficient adjunct of observation. In 1914, the first successful movie of the eclipse was secured in Sweden, and in 1918, Frost of the Yerkes Observatory first applied the cinematograph to registry of the flash spectrum, and Stebbins tested out his photoelectric cell on the corona, making the brightness 0.5 that of the full moon. In 1914, in Russia, and again in 1919 on the Atlantic, the obvious advantages of the aeroplane in ecliptic observation and photography were sought by the writer, though unsuccessfully. The photographic tests, however, conducted in preparation for these expeditions, proved the entire practicability of securing eclipse results of much value, independently of clouds below. Eclipses in the near future will be total in Australia, about 6 minutes on September 21, 1922. In California and Mexico, about 4 minutes on September 10, 1923, and along a line from Toronto to Nantucket, about 2 minutes on the morning of January 24, 1925. To all spectators, savage or civilized, scientist or layman, a total eclipse is wonderful and impressive. Langley said, "The spectacle is one of which, though the man of science may prosaically state the facts, perhaps only the poet could render the impression." Very gradually, the moon steals its way across the face of the sun. The lessened light is hardly noticed. If one is near a tree, through whose foliage the sunlight filters, an extraordinary sight is seen. The ground all about is covered with luminous crescents, instead of the overlapping disks to which were there before the eclipse came on. In both cases, they are images of the disk of the sun at the time, and the narrowing crescents will be watched with interest as totality approaches. Then the shadow bands may be seen flitting across the landscape like visible wind. They are probably related to our atmosphere and the very slender crescent from which true sunlight still comes. Then, for a few seconds, the moon's actual shadow may be caught in its approach. Very suddenly, the darkness steals over the landscape, and totality is on. How lucky if there are no clouds. Every eye is riveted on the incomparable corona, a silvery, soft, unearthly light with radiant streamers stretching at times millions of uncomprehended miles into space, while the rosy, flaming protuberances skirt the black rim of the moon in ethereal splendor. Then, it is now or never with the observer and photographer. Months of diligent preparations at home, followed by weeks of tedious journey abroad, with days of strenuous preparation and rehearsals at the station, all go for naught, unless the whole is tuned up to perfect operation the instant totality begins. It may last but a minute, or even less. In 1937, however, the total eclipse will last 7 minutes, 20 seconds, the longest ever observed, and within half a minute of the longest possible. All is over as suddenly as it came on. The first thing is to complete records, develop plates, and see if everything worked perfectly. There is great utility back of all eclipse research, on account of its wide bearing on meteorology and terrestrial physics, and possibly the direct use of solar energy for industrial purposes. With this purpose in view, the astronomer devotes himself unsparingly to the acquisition of every possible fact about the Sun and his corona. Considering the Earth as a whole, the number of total eclipses will average nearly 70 to the century. But at any given place, one may count himself very fortunate if he sees a single total eclipse, although he may see several partial ones without going from home. Then too, there are annular or ring eclipses, averaging 7 and 8 years. But had one been born in Boston or New York in the latter part of the 18th century, he might have lived through the entire 19th century and a long way into the 20th without seeing more than one total eclipse of the sun. In London in 1715, no total eclipse had been visible for 6 centuries. However, taking general averages and recalling the comparatively narrow belt of total eclipse, every part of the Earth is likely to come within range of the moon's shadow once in about 3.5 centuries. The longest total eclipses always occur near the equator. This is because an observer on the equator is carried eastward by the Earth's rotation at a velocity of about 1,000 miles per hour, so that he remains longer in the moon's shadow, which is passing over him in the same direction with a velocity about twice as great. The general circumstances of total eclipses are readily foretold by means of the ancient Chaldean period of eclipses known as the Saros. It is 18 years and 10 or 11 days in length, according to the number of leap years intervening. In one complete Saros, 41 solar eclipses will generally happen, but only about 1/4 of them will be total. The Saros is a period at the end of which the centers of Sun and Moon return very nearly to their relative positions at the beginning of the cycle. So, in general, the eclipse of any year will be a repetition of one which took place 18 years before, and another, very similar in circumstances, will happen 18 years in the future. 3 periods of the Saros, or 54 years and 1 month, will usually bring about a return of any given eclipse to a particular part of the Earth, so far as longitude is concerned, though the returning track will lie about 600 miles to the north or south of the one 54 years earlier. Paths of total eclipses frequently intersect, if large areas like an entire country are considered. Spain, for instance, where total eclipses have occurred in 1842, 1860, 1870, 1900, and 1905. Besides crossing Spain, the tracks of totality on May 28, 1900, and August 30, 1905, were unique in intersecting exactly over a large city, Tripoli and Barbary, on both of which occasions the writer's expeditions to that city were rewarded with perfect observing conditions in that now Italian province on the edge of the Great Desert. Kepler was the first astronomer to calculate eclipses with some approach to scientific form, as exemplified in his Rudolphine tables. His method was, of course, geometrical, but Lagrange, who applied the methods of more refined analysis to the problem, was the first to develop a method by which an eclipse and all its circumstances could be accurately predicted for any part of the Earth. To many minds, the prediction of an eclipse affords the best illustration of the superior knowledge of the astronomer. It seems little short of the marvelous. But recalling that the motion of the moon follows the law of gravitation and that its position in the sky is predictable for years in advance with a high degree of precision, it will readily be seen how the arrival of the moon's shadow, and hence the total eclipses of the sun, can be foretold for any place over which the shadow passes. All these data, derived by the mathematician, are known as the elements of the eclipse, and they are prepared many years in advance and published in the nautical almanacs and astronomical ephemerides issued by the leading nations. Buchanan's Treatise on Eclipses will supply all the technical information regarding the prediction of eclipses that anyone desirous of inquiring into this phase of the problem may desire. So important are total eclipses in the scheme of modern solar research, and so necessary are clear skies in order that expeditions may be favored with success, that every effort is now made to ascertain the weather chances at particular stations along the line of eclipse many years in advance. This method of securing preliminary cloud observations for a series of years has proved especially useful for the eclipses of 1893, 1896, 1900, and 1918. And had it been employed in Russia for a totality of 1914, many well-equipped expeditions might have been spared disaster. The California and Mexico totality of 1923 does not require this forethought, as the regions visited are quite likely to be free from cloud. But observations are now in process of accumulation for the total eclipse of 1925. The outlook for clear skies on that occasion, the total eclipse nearest New York for more than a century, is not very promising. The path of totality passes over Marquette, Michigan, Rochester and Poughkeepsie, New York, Newport, Rhode Island, and Nantucket about 9 in the morning. Everyone who saw it will remember the last total eclipse of this part of the world, on June 8, 1918, visible from Oregon to Florida. Many will recall the last total eclipse that was visible before that in the eastern part of the United States, on May 28, 1900, visible in the narrow path from New Orleans to Norfolk. One's father or grandfather will perhaps remember the total eclipse of July 29, 1878, which passed over the United States from Pikes Peak to Texas. It was the writer's maiden eclipse. And another on August 7, 1869, which passed southeasterly over Iowa and Kentucky. On all these occasions, the paths of total eclipse were dotted with numerous observing parties, many of them equipped with elaborate apparatus for studying and photographing the solar corona and prominences, together with a multitude of other phenomena, which are seen only when total eclipses take place. Looking forward rather than backward, a striking series or family of eclipses happen in the future. It is the series of May 1901 and 1919, reoccurring again on June 8, 1937 over the Pacific Ocean, June 20, 1955 through India, Siam, and Luzon, and June 30, 1973, visible in Sahara, Abyssinia, and Somali. Already in 1919, this totality was 6 minutes 50 seconds in duration. In 1937, as already mentioned, it will be 7 minutes 20 seconds. And at the subsequent returns, even longer yet, approaching the estimated maximum of 7 minutes 58 seconds, which has never been observed. This remarkable series of total eclipses is longer in duration than any others during 1,000 years. Its next subsequent return is in 1991, occurring with the eclipsed sun practically at noon in the zenith of Mount Popocatépetl in Mexico. Whether may be the progress of solar research during the intervening years, it is impossible to imagine the alert astronomer of that remote day without incentive for further investigation of the sun's corona, in which are concealed, no doubt, many secrets of the sun's evolution, from nebula to star. End of section 30.